Through the application of robots and automation in agriculture, we are undergoing a revolution in the way that we manage and harvest crops, which is resulting in a significant increase in both efficiency and productivity across broad swaths of farmland. These technological advancements are not only revolutionizing conventional farming methods, but they are also tackling significant difficulties such as the lack of available labor and the issue of sustainability. A comprehensive look at the ways in which robots are altering the agricultural landscape and managing millions of acres of farmland on a daily basis is presented here. Number 5. Highly developed robots for harvesting. In the context of contemporary agriculture, harvesting robots have arisen as indispensable equipment meant to address the labor-intensive process of collecting crops. In order to accomplish harvesting activities in a precise and effective manner, these robots make use of advanced technology. As a result, the amount of physical labor that is required is greatly reduced. Technology and working procedures. Vision systems. Intelligent robots are outfitted with cameras that have a high resolution and sensors that can detect multiple spectral ranges, which allow them to capture detailed photos and data on the crops. With the use of these visual systems, the robots are able to determine the ripeness, size, and quality of the product with an impressive degree of precision. Artificial intelligence, AI, and machine learning. AI systems examine visual data in order to make decisions in real time on which crops are ready to be harvested. Over the course of time, machine learning models enhance these decisions by gaining knowledge from previous harvests and adjusting to a variety of crop circumstances. Robotic manipulation. These robots are able to handle delicate products such as tomatoes and berries without inflicting any damage to them because they are equipped with precision arms and grippers. In order to ensure that the handling is delicate, soft touch grippers and vacuum-based devices are frequently utilized. Examples: tomato harvesters. Machines such as the tomato harvester use hydraulic arms to carefully harvest tomatoes from the vine and sort them according to their level of ripeness and size. This guarantees that the product is of great quality and lowers the likelihood of it being bruised. Apple harvesters. Apple picking robots and other devices like them employ sophisticated sensors and grippers to pick apples from trees, thereby reducing the amount of waste produced and improving the efficiency of sorting procedures. Number 4. Farming equipment, including tractors that operate on their own. On the whole, autonomous tractors and other farm equipment are a huge step forward in terms of technological advancement in the agricultural sector. When it comes to tilling, planting, fertilizing, and cultivating, these machines are capable of doing a wide range of tasks with minimal involvement from humans. When it comes to technology and operation, autonomous tractors make use of high-precision global positioning system, GPS, and inertial navigation systems. These technologies allow autonomous tractors to follow precise tracks and carry out duties with centimeter-level accuracy. By doing so, overlaps and gaps are reduced, which ultimately results in more efficient field operations. The sensors that are installed on these tractors are responsible for gathering information regarding the soil conditions, crop health, and environmental elements. These data are utilized to make dynamic adjustments to processes, which optimizes the utilization of resources and improves outcomes. The use of machine learning allows these systems to continuously improve their operations through the use of machine learning. It is possible for them to adjust to a variety of field conditions, crop varieties, and weather patterns, which results in an increase in total efficiency. Examples include John Deere's AutoTrack, which is a technology that enables tractors to travel fields on their own, thereby minimizing the likelihood of human error and ensuring more precision in planting. When it comes to efficiently managing field variability is also helpful. Automated seeders. Machines such as the precision seeder plant seeds at appropriate depths and spacing, hence increasing crop yields and minimizing the need for manual planting procedures. Number 3. Using drones for the purpose of data collection and crop monitoring. In a nutshell, drones are rapidly becoming indispensable instruments for the purpose of monitoring the health of crops and gathering data across vast tracts of agricultural land. By providing a bird's eye view, they assist farmers in making well-informed decisions on the management of their crops and the distribution of resources. Technologies and operations, aerial imaging, and sensors. Drones that are outfitted with high-resolution cameras, multispectral sensors, and thermal imaging are able to gather a great deal of information regarding the soil and crops. It is possible to discover problems such as pest infestations, nutrient deficits, and water stress with the use of these observations. Systems for the analysis of data. In order to develop insights that may be put into action, the data that is collected by drones is processed using sophisticated software. This includes the creation of precise maps of the health of the crop, the levels of soil moisture, and the variability of the field. Monitoring in real time. Drones have the capability to provide feedback in real time, which enables farmers to make prompt adjustments to their practices. These adjustments may include the application of targeted treatments or the modification of irrigation. Precision Hawk is an example of a drone system that offers high-resolution imagery and data analytics for the purpose of monitoring crop health and optimizing management procedures. Utilizing cutting-edge photography and global positioning system (GPS) technology, the DJI Phantom 4 RTK drone is utilized for the purpose of generating precise field maps and monitoring the growth of crops. Number 2. Management of weeds by robots. To provide an overview, weed control is an essential component of crop management, and robotic systems are specifically intended to ensure that this task is met with precision. Traditional techniques of weed removal are not as effective as these robots, which give a more targeted approach to the task. Technology and working procedures. Computer vision. In order to differentiate between crops and weeds, robotic weeders make use of computer vision systems. With the help of this technology, they are able to recognize and eliminate weeds solely on the basis of their form, color, and growth patterns. Mechanical and chemical methods. Some robots eradicate weeds physically by using mechanical instruments such as revolving blades or brushes. Other robots will employ chemical methods. Herbicides are applied by some people in a highly targeted manner, which reduces the amount of chemicals used and minimizes the impact on the environment. Adaptive learning. These robots frequently make use of machine learning in order to enhance their weed identification and removal operations over time. They do this by taking into account a variety of weed species and the conditions of the field. For instance, WeedBot is a robot that employs imaging technology and artificial intelligence algorithms to detect and eliminate weeds in row crops. This eliminates the need for manual weeding and the administration of herbicides. EcoWeeder is a mechanical weeder that eliminates the need for the use of chemicals by removing weeds through the use of rotating blades. This provides an alternative that is more environmentally friendly. Number 1. Technologies that allow for precision agriculture. In a nutshell, precision agriculture is the practice of maximizing crop output and resource utilization through the utilization of data-driven methodologies. Robotics and automation play a vital part in the implementation of these technologies, which ultimately results in farming techniques that are more effective and environmentally friendly. Technology and working procedures. Information integration. Precision agricultural systems include information from a wide variety of sources, including satellites, drones, and ground sensors. With the help of this information, precise field maps can be created and resources may be managed more efficiently. Variable rate application. Thanks to technological advancements, it is now possible to apply inputs like water, fertilizers, and pesticides at varied rates, depending on the individual requirements of different locations within a field. By taking this technique, waste is reduced and crop yields are increased. Systems of management that are automated. Data is processed by farm management software, which then provides recommendations and automates decisions regarding planting, irrigation, and crop management. Examples of variable rate fertilizers. Systems such as the Yara N sensor modify the quantity of fertilizer that is administered based on the current levels of nutrients in the soil and the requirements of the crop. Smart irrigation systems are computerized systems that make use of weather forecasts and data on soil moisture to optimize irrigation schedules. This helps to reduce the amount of water that is used while simultaneously enhancing crop health. Final thoughts. Through improvements in efficiency, precision in production, robots and automation are bringing about a revolution in the agricultural industry. Using technologies such as advanced harvesting robots, autonomous tractors, drones, robotic weed control, and precision agriculture, it is now possible to handle millions of acres of farmland with an accuracy that has never been seen before. The implementation of these innovations addresses important difficulties in modern farming, such as labor shortages, resource management, and sustainability, thereby opening the way for an agricultural sector that is more efficient and resilient. Thanks for joining us in today's deep dive into how robots are revolutionizing agriculture and transforming the way we harvest millions of acres of farmland every day. If you enjoyed the video and found it insightful, make sure to hit that like button and subscribe to our channel for more content on cutting-edge technology and its impact on various industries. We'd love to hear your thoughts, so drop a comment below and let us know which tech innovations you're most excited about. And don't forget to ring the bell for notifications so you never miss an update.